All right, welcome to the Oklahoma Weather Show, episode number 26. Here it is now, July 2nd, 2 days away from July 4th. We are now well into the summer season. Haven't had much of a severe weather season, although we've had certainly been getting some nice rainfall in the last couple of days. I just saw yesterday afternoon and this morning, southern Oklahoma, parts of the state there got about 2 to 3 inches of rain. We're just going to talk all sorts of weather-centric things today, talk about severe weather forecasting, whatever else our conversation kind of takes us. So, Brad, good to see you. Haven't seen you in a while.
Hey guys, yeah, I thought this would be a good idea. A lot of people always hear our forecast, but they don't necessarily know what we forecast or how we forecast. So I think we're going to talk about a little everything. A lot of times it's interesting, what type of forecast we talk about. I know a lot of people are talking about, Tropical Storm Arthur right now and the forecast path of where Arthur may go and where Arthur may be. And so I thought this was interesting. Not a lot of uncertainty here with Arthur. Let's see if I can make this a little bit bigger.
Hey, Brad, did you see that the National Hurricane Center actually, I'm going to pull it up right now. It's not for broadcast use. I actually tried to import it into WSI, but I'm going to pull it up right here. So they started doing their storm surge maps, and since it's an experimental project, they actually will not allow it to be imported into any type of WSI, which is why we can't import the HUR. But this is actually pretty cool.
Well, here's the track too, Damon. I was going to start off by saying, well, certainly not a lot of question on where Arthur may be going. I mean, I think this is obviously you don't need a meteorologist to determine the spaghetti models. How many models are in the spaghetti? It's like 10, 12. Well, anyway, every single type of model puts this out, and so clearly it's going to go off the coast, Carolinas, and this is going to screw up things for people off the Outer Banks, really from Norfolk, where you're from, down to Myrtle Beach, which is an awesome place this time of year. But I think one of the big questions is intensity. It always seems like spaghetti models do a great job on the mean of where a storm's going, but not necessarily the intensity of these storms.
I felt really bad for meteorologists on the East Coast who about 2 days ago had to start putting this in their forecast for July 4th, because no one on July 4th wants a hurricane coming in.
Yeah, I've had a lot of family and friends from Virginia Beach, because that's where I grew up. For those of you who don't know, they've been writing me nonstop. Is this going to ruin my weekend? And I'm like, well, right now it looks like just a Thursday, Friday event for the Carolinas and Virginia, and then it looks to scoot on off. So we'll hope that for those of you for the weekend, it's looking good, hopefully.
Yeah, on the forecast track, with the synoptic event, it's always pretty easy to know where it's going, but the intensity, and then, of course, the rain out of this and inland tornadoes. I mean, once we start getting down from the synoptic scale, large scale, to micro scale, I mean, I know for us here, you guys, we deal with so much small scale event that we don't do a lot of tropical forecasting, which where these storms are going doesn't necessarily seem to be the hard part. It's just knowing how strong it'll get and the favorable conditions on, will there be inland tropical storms and flooding. I remember, what was it, Hurricane Isabel.
Oh yeah, I remember that one.
That one dropped, 20 inches of rain, and while it wasn't that big of a hurricane, a Cat 1, it slowed way down over the Carolinas and just, I don't know, it was like $1 billion flood disaster.
I remember that one.
Because it's a Cat 1 may landfall doesn't mean that it's not a big deal.
Oh, yeah. No. I actually remember, Brad, Danielle, we were in Asheville at this time. It was, I think, in the summer of 2004. And what had happened was we had Ivan come up through Florida, and then we had, oh gosh, there was another one. But I remember I lost water for 1 week.
Oh yeah, I remember that.
And then I lost power the next week, and I don't know what's worse.
It was Francis.
Francis, Francis and Ivan.
Well, it was actually 3 storms. Ivan was the third one. That's when we lost power in Asheville. Francis was the very first one. That's when they didn't plan on all the water coming down.
I lost water.
Wananoa River, and it took out the water lines up near Mount Mitchell. and flooded Biltmore Village. I was actually working in Biltmore Village at the time, and that was a big problem.
I was going to say, definitely, like, I remember that one, and I tell you what, if you've never been without water for days, it is not something you want to live through, because having to go and pour jugs of water from the store in a bowl, heat it up in the microwave, and then bring it back just to take a shower, like, it's terrible.
That was bad.
2004? Jonathan, where were you in 2004?
Mason City, Iowa.
All right.
You know, funny story, actually. I want to share this before I show the screen grab of the Hurricane Center storm track. So I actually met Jonathan Conder. I was on a job interview back in February. I went up to Mason City, Iowa, and I remember getting off the airplane and thinking, wow, there's not much up here at all. But I remember going to the station.
Notice how Jonathan's not there anymore.
Yeah, I remember I went to the station, and it was Jonathan's last day, and I remember him saying, he probably doesn't remember me at all, but I remember him saying, oh, I'm headed down to Oklahoma City, You were doing mornings down there, but it was a cold February afternoon in Iowa where you had some snow on the ground, everything's brown. Jonathan, wasn't that old TV station like an old church or something like that?
It was a what do you want to call it? Back in the day, it was like a church, but over the radio. What do they call that? There's a name for it. It was a church, but they did radio broadcasts out of it weekly. And then it changed to, a TV station, but the design was really weird. Some TV stations are they're really, I don't know, it was weird. Our newsroom was kind of open in a balcony, so you had the newsroom pit in the center, and then you had to go up this almost like a ladder to the second floor, and it was like a balcony all the way around. And I mean, we kind of had a closet for an office. We could get onto the roof. That's where we did weather observations for the National Weather Service. But it was really weird. They rumored that it was haunted by a ghost, and at night you could hear the ghost typing on a keyboard. So if you were there late for severe weather, I get goosebumps.
Modern ghost.
Talking about it. You could hear someone typing. The sound is someone typing on a keyboard, and you're like, "What is that?" and you'd walk out, and you'd be like, "I hear it." And it was a different tempo and pace. And you're like, "Is that a wind blowing through a vent or something?" And actually, I don't think it is, but that's if you remember the story about Jody Husentrut.
That was the station where the girl went missing, right?
Yeah, she was a reporter and a morning anchor, and she was abducted and assumed murdered. They never found her body. So that I actually worked with people who anchored that morning that she should have been at the newscast. So.
I still ask for let's help find Jody. So if she was murdered, I mean, are there some people thinking that she's still alive?
No, I think the assumption is she's
gone.
She was abducted and murdered. That's the assumption.
There's actually, when I was first working in North Carolina, I was a production assistant at WLOS, and before WLOS, which is an ABC affiliate for the Greenville, Spartanburg, Asheville market, before they moved to their new studios down, I think it was Fletcher, which is South Asheville, they were right by the Grove Park Inn, and they were convinced that the station there was haunted as well by what they said was the Pink Lady, and that there'd be nights when the cameras would just start moving, and all of a sudden, like, you just kind of felt like someone was over your shoulder, always looking. But if you ever go to Asheville, I mean, the Grove Park Inn was, you remember how the Grove Park Inn, kind of had that, it was a 1920 style hotel.
Damon, they host a paranormal conference workshop every year at the Grove Park Inn. And my wife and I just happened to stumble across this. We were just going up there for a date. And my wife knew the professor, Professor Dr. Forston from Montreat University. He was hosting the event. And he took us in. He was staying in the Pink Lady room. I don't know why. I wouldn't stay in a haunted room. But he had a Geiger counter. And we're going around this room. And he was explaining the radiation process, and it was really creepy. There were some readings that he's like, I can't explain why you're picking up a sensor reading where you are. It's electromagnetic. You shouldn't be picking up a frequency there. So that was the point we left. We're getting a little off subject.
I know we're getting a little off subject. Actually, so I want to go back. Go ahead, Jonathan. What's up?
Bring it full circle. What's the funny story about meeting me at KIMT?
Oh yeah. Anyways, so
finish the story.
Anyways, so I met Jonathan. Long story short, I met Jonathan probably long before he even knew who I was. And okay, yeah. Anyways, I've known Jonathan for a long time.
No, you got to tell the story.
What's the story?
No. The story was Damon walks in. He's interviewing with the chief meteorologist, walking through, and he walks up and he sees me in a suit. And he looks down, and I'm wearing hiking boots.
That's
not
right.
Brush shoes. I'm wearing hiking boots, and he's like, "Who is this guy that he wears hiking boots on air?" And the moral of the story is, it had snowed that morning, and I didn't feel like getting my dress shoes all dirty, so I knew I had to tromp through the snow, so I wore my Echo Track 2 Gore-Tex boots to work, and I didn't care. It was my last day.
And I remember that being my first job interview I ever had, and I was thinking, so is that what people do? Do they just wear boots like to work? So for about 5 years, until I saw you again here in Oklahoma City, I kept thinking people in Iowa, they don't wear dress shoes with their suits. They wear boots with their suits.
That's funny.
It was a one-time deal.
Yeah. So hey, I want to go back over actually to this.
People in Oklahoma wear sports coats, right? When you were at Good Morning America,
yeah.
Didn't they ask you? They said, do people in Oklahoma wear sports coats? I guess it's because every time they watch a video of us on YouTube, it's because of severe weather, and we take some of our clothes off.
Yeah, they're like, we want to make sure that you own a suit. Do you own a suit? Because we wear suits here. And I'm like, yes, I own a suit. But yeah, I think they were just watching our tornado coverage, and yeah, no one really wears a suit jacket when
it's a little warm in there. I mean, the humidity in the studio. I mean,
it's funny.
Take some clothes off.
Hey, let's get back on topic here. So what I wanted to show was this new experimental product that just came out this past year with the National Hurricane Center. And what they're doing here is actually they're able to forecast storm surge. So if we go down, let's say we're going down into North Carolina here, you can actually zoom in. Now this is as close in as you can zoom, but they will project. You can see the blue would be up to 3 feet above ground. Potential storm surge flooding, yellow would be greater than 3 feet above ground. I think emergency managers would probably like to see us be able to get a little bit closer so they can pinpoint the streets down to this. But yeah, so this is actually a pretty cool product, and I think once it's no longer experimental, which I don't know how long a product has to stay experimental before they push it out, but once that happens,
is this the slosh model? Is that what they call this thing? I know at one point they were calling it the slosh model. I know we get to look at tropical stuff as much as we like, but when it's boring in Oklahoma, we can't.
Yeah. So this is, I think it'll be cool in a couple weeks. Maybe we'll get one of our meteorologists from our station, either in Greensboro or Orlando, and they can talk about what they're doing with hurricane forecasting, because there's a big difference between forecasting hurricanes and forecasting severe weather. I mean, hurricanes, you see them spinning out in the ocean for days on end, and you can basically prepare yourself. But severe weather, we kind of get an idea how many days in advance we're going to have a chance for severe weather, but it's a lot more immediate.
On a side note, at 5 o'clock today, I'm actually doing a little hit on the tropical storm. So, FYI, you want to tune in.
I think it's what's the timeline? It'll become a hurricane in 24 hours. Is that what
by Thursday?
By Thursday. Yeah, I think I saw Thursday at like 8 a.m. or something like that. But yeah, or 8 p.m. What are we looking at here? Well, that's a mess. All right, so let's talk about severe weather forecasting. What do you say?
Okay.
I guess I have to unmute my microphone. Hey, look, I'm like, why aren't you guys listening to me? Hey, so I'll start. For me, on a severe weather day, here's where I like to start. I like to start kind of high with winds and kind of work my way down. So I usually pick about 500 millibars to look at what we've got going on. Of course, not hard to see the ridge and the trough. This is today, by the way. I think this was 0Z this morning. Big ridge in the west, northwest flow here. You see that, sure, there's some 500 millibar winds north in Kansas, more or less just cold air advection at the base of this ridge. And then northeast, of course, guys, that's interesting because good southwesterly flow, pretty strong, 500 millibar winds at looks like 50, 60 knots there in parts of Pennsylvania. And then the next thing I do is I kind of work. Sorry about that. I work my way down. I would pick 700 millibars next to look at. Am I seeing more turning with winds? What do winds look like? And then kind of work my way on down as far as winds go. And that's kind of how I start with forecasting severe weather, and then go on to Cape next. And this was Cape today. So sure, you saw the 500 millibar winds were strong in Kansas, but I think that was North Kansas. Essentially, cold air advection, you don't have any Cape. Convective available potential energy, we love Cape. But big Cape up around D.C., and of course with that southwesterly flow, D.C., northeast, parts of Pennsylvania today. I mean, you wanted severe weather, that's probably part ways to go, but of course, sin. I always thought the word sin was funny. Cape makes sense because convective available potential energy is kind of like the perfect acronym, but sin, convective inhibition, it doesn't seem right.
We like acronyms in meteorology. Hey, Brad, I'm not seeing your screen change.
Are you serious?
I am.
Are you?
Oh, you gotta click me, click my face.
That's your one.
Then you can. Yeah.
So for everyone out there, there's a whole lot that goes into severe weather. So Brad's just kind of explaining one of the things that he looks at and how he goes about forecasting. So I'm sure a lot of you guys are going to talk about other parameters as well.
We all have different ways of doing it, and I'm a big hodograph guy. I pulled up some screen shares of hodographs, but not everybody uses hodographs. Any of you guys love looking at hodographs?
I do. I like looking at hodographs. Usually for me, the number one thing that I do before I even go in towards severe weather forecasting is understanding climatology. I'm kind of a big climatology guy, knowing what's normal for this time of year, what's not normal. That kind of gives you at least a good starting point. I know that going in towards March, April, especially May, you begin to look for things in the small details a lot more closely. If it's July and I see southwest flow coming in here, my first sense of big tornado outbreak is not going to pop up because I know that climatology says July, Oklahoma, usually not. So usually understanding climatology is a really good place to begin with.
Yep.
Just my 2 cents.
Indeed. Well, I could show, here I also have the SIN for today. Which, I was going back to, dadgummit, where did this screen share thing is kind of cool, but it's kind of confusing too.
It can be a little weird, yeah.
Yeah, it's a little weird. So here's SIN today, right here, convective inhibition. We saw that there was CAPE of 3,000 to 4,000 joules, and for severe weather, it really depends. You can have 3,000 to 4,000 joules, but of course plenty of SIN that would not allow it to occur, or you don't even necessarily need that much CAPE. You could have a ton of wind shear. So northeast from DC to central Pennsylvania, parts of New Jersey today, since the SIN here is gray, you look over here on the left side, that's the scale. The white area would indicate that there's not a lot of inhibition for storms to fire. So I know earlier SPC had the slight risk. Now the slight risk out for the Northeast. One
thing I've noticed, especially in severe weather forecasting, is that each part of the United States is different, and what you have to look for. What we look at here in Oklahoma is probably different in the Southeast. I've seen some low CAPE days in the Southeast, Alabama, Mississippi, Georgia, turn into a moderate risk because they can get by with a lower amount of CAPE. Here in Oklahoma, we kind of tend to need all your big guns out. You know, your cape needs to be high, your sin needs to be low.
Why do you think that is? Why do you think? What's your opinion on why you think Alabama gets away with less cape and with simply more shear?
I'd say probably your you got moisture.
Moisture, yeah.
Yeah, you got your Gulf much more in play now. They deal with a lot of rain wrap storms there. You get these low top supercells that can just kick right on through there. And again, it can be really, really challenging sometimes because I'll be going through and I'll see the Storm Prediction Center put out a moderate risk for severe weather in the southeast, and I'm thinking, all right, what are they looking at down in the southeast that's different than what I'm seeing, because I'm not seeing a whole lot. And then you begin to realize, it could be February, you get dew points in the 60s and 70s. You got your jet stream kicking in through there, so you don't need a lot of tape to get some nasty storms down there.
Hey, Brad, go back to that map.
Your area. I could hear a lot in the newsroom there.
Oh, sorry. Can you go back to that map?
Oh.
Can you pull it up?
Yeah, which one was it?
The one with the sin.
Oh, yeah.
So I was just going to talk about some of the other parameters since you had it up.
Yeah.
There you go.
Yeah. So for those of you that are watching out there, there are other elements, and now obviously since I'm talking, it's on Damon for some reason. I can see his face and I can't see the map anymore, but I imagine on that left-hand side you guys are seeing a bunch of other parameters, and there's helicity, there's the EHI, which is the Energy Helicity Index, and that's a good measure for figuring out if you're going to have supercells or powerful tornadoes or something like that. And so there's a lot of different elements there on the side so that we look at. So it's not just CAPE, it's not just SIN, but it's the EHI, and it's you have lifted index. And a lot of times Damon will talk on air about something called cloud heights. So when we look at severe weather and forecasting, there's something called the LCL, or the lifted condensation level, and so that's a good indication whether you're going to have you might have a better chance for tornadoes as well. So there's a lot to go into it. So I just want to kind of talk about those elements too.
Oh, there's a ton that goes into it. And one thing that I've noticed a lot, especially with our interns that come into KOCO, is that the first thing they ever just learn about in school, it seems, is CAPE. And they think if you've got CAPE, that's all you need. And that is only one. It's almost like I almost look at tornado forecasting like you have your 7-layer dip, and you need to have each layer there. If you have, let's say, you have the top layer but you don't have anything else, it's not going to happen. I mean, especially in the summertime, we can get some incredible CAPE values out here, but hey, we've got a strong cap going on. We have no shear. I'm a big fan of, usually when I go into a severe weather day, is looking at CAPE, SIN, energy helicity, LCL. Because if you have a lot of shear, but the base of your clouds are going to be at 3,000 meters, well, then you're not going to be getting a tornado out of that. So there's a lot, and I feel I would almost wish I could have gone back into the 1950s and seen what it was like to try to forecast tornadoes out there when they were making their first tornado warning and issuing their first tornado warning, because they didn't have that type of stuff that we have now.
Yeah, I think too, some people maybe watching us may be a little overwhelmed with talking CAPE and LCL and EHI, and I'd say for the student or the weather fan that's saying, I want to learn these things so I can. Danielle, would you mute your mics? I hear your keyboard's real loud. People have the EHI or the LCL. Learn what the terms mean, and then learn what level you need them to be to produce. Because just because you have one, not the other, doesn't mean you get tornadoes. But sometimes you can't have a loaded gun sounding per se, where every single element comes together. That rarely happens. I think once or twice in my career have I ever seen just the perfect sounding where you're saying, look, there's no way there's not going to be a tornado. And then there's always the chaos of the atmosphere. Something comes in, something happens. So what was it Ed Brotak always said at the UNCA, always, I want to get this right. He goes, well, I guess I can get the gist of it because I'm not going to get it right. There are always is an exception because there is no always, or something like that.
I remember him saying something to that, yeah.
Weather should always go like this. That's not going to happen. There is no always in forecasting.
You know, trying to forecast an EF5 tornado outbreak is pretty simple to do. Last year, you know, May 20th, May 31st, those are the easy days to forecast. When you see your jet stream coming in, you've got hardly any cap, you've got your moisture in play, you've got, you know, some high energy helicity values. Those are the easy days to forecast. The hard days are the forecast, those moments when, you know, you might have a quick tornado spin up for about 10 minutes or so. Those are the hard days to forecast.
I agree, and you know that's generally what we have this time of year. I know I just saw the report, 3 confirmed tornadoes in Beaver County, June 22nd. I think there was a slight risk for that, and maybe a 2% or a 5% ring. I can't remember. Maybe you remember, Damon, but I know you were working. One was rated EF1 last week.
Was it really?
Yeah,
you know, there's a
EF1.
And when you look at the climatology and you look at those tornado percentage rings that they put out, the Storm Prediction does, and they'll put out a 2%, 5%, 10%, so on. That's all based off of climatology. You know, so for instance, on May 20th, we have climatology states that on May 20th in Moore, Oklahoma, or within 25 miles of Moore, Oklahoma, you have about a 1.2% chance of there being a tornado on any May 20th within 25 miles. That day, we had a 10% tornado ring. So what we were saying is that the odds of a tornado today was about 10 times greater than normal. Now, if you look at climatology, and in January, the number of, the percent for a tornado and more is much less. So if you see a 10% tornado ring in January, that's completely different. I know numbers and percentages and climatology, it doesn't really sit well with many people because it can be very confusing when you think about percentages, but there is a difference between a 10% tornado ring in January and then one in June. So when you had that tornado last week, and I think what did you say, you had a 2% ring?
It was either a 2 or a 5.
So really, this time of the year, that part of the state, there's usually about a 1% chance of a tornado within 25 miles any given year. So if you had a 2% chance or a 5% chance, the odds weren't that much higher than normal, but they were still there. So yeah, there's a lot that goes into tornado forecasting.
You know, and I know, of course, you brought up May 20th and the 10% ring, and a lot of people go back and say, well, that was only a moderate risk day, and you can have a 10% and a slight risk. I mean, that is possible. That is part of the realm. But a lot of people afterwards saying 10% moderate risk, shouldn't it have been more? Shouldn't the percentage have been higher than 10%? But, you know, it's always so easy to criticize or to bring up something after the event. How many days is there a 10% and there's not a single tornado? It happens all the time. And so, you know, a lot of people are going that way. Hey, Jonathan, I know. How do you start? Let's go to a severe weather day. Where do you begin? Where do you begin your forecast?
That's a really good question, and I think you gotta. It's a good question. It's a hard answer because what happened the day before? I'm a huge fan of. Mesoanalysis, and is atmosphere turned over because of the convection the day before? So that's a big issue, and we saw that this last weekend. We had, what day was that? It was storms on Friday, and they came through, and they lingered. No, storms into Saturday morning were ongoing, and we didn't see enough afternoon sunshine, so that there was too much sin or not enough instability. So I usually do a really thorough mesoanalysis. I'm going to look for outflow boundaries. Anytime you can find a residual boundary from the night before, you can find enhanced low-level shear. So that's a big thing. I've forecasted and storm chased many tornadoes that formed on outflow boundaries. So I'm a huge outflow boundary guy. Those are what I consider kind of sleeper days. A lot of people will look, oh, here's a cold front, here's a triple point, here's a dry line. On those big days, the target is really obvious. But on those quiet kind of sleeper days, where you have to be really good at doing that mesoanalysis, and a lot of times those boundaries may not fire, and they just don't produce, and sometimes they do, and you can nail the forecast for the tornado. So good mesoanalysis. I'm a big 500, 850 crossover guy. I'm all about directional and speed shear. That for tornadoes, and I'm not talking about tornadoes that may form on a line echo wave pattern or tornadoes that may form the tail end of a squall line. I'm talking about supercellular, discrete thunderstorms that produce tornadoes. I'm a straight 500 millibar, 850 millibar crossover. And if it has to be balanced, it has to be enough speed shear and directional shear. And I know the weather enthusiasts that are listening might understand that, but for the people who don't understand what I just said, there's two types of shear. So imagine you have a thunderstorm updraft, right? And this is a mesocyclone or the updraft, and you need two things to have a long-lived updraft. You need speed shear. So you need the winds aloft to be stronger than the winds at the surface, and that will tilt over your updraft. If you don't have speed shear, the updraft is vertical, the rain goes up, and it comes down, it collapses the updraft. Those are your pulse severe storms. They might rotate for an hour, but then they collapse on themselves, or the cold pool will come in and snuff it out, and they're outflow dominant, or they get snuffed. So let's say we have speed shear. Now you need directional shear, which is the changing of direction with height. So at the surface, you have south winds, which are low-level winds, and then aloft, you have your jet stream winds coming out a different direction. So that causes the updraft to rotate. And I always teach the kids at the weather school, like, if you take a pencil and put it in your hand, and if you roll it, that's kind of directional shear. You're going to get the spin. You're going to get the pencil to spin. So you need those two ingredients, depending on the time of the year. In May, if I don't have 50 knots at 500, it's not a tornado. It's not a violent tornado day for me. You gotta have You have to have 50 knots at 500 millibars. So that's my rule of thumb. And then I like to see about 45 degrees directional shear from 850 to 500. That's my rule of thumb. And a lot of times, Twister Data, that website has a really good, for the NAM at least, that will show the crossover. So I like to see, not 90 degrees crossover, not 20 degrees, but about 45 degree crossover, and the winds aloft have to be faster than the winds at 850. That is my rule of thumb, cheap, poor man's version of finding out where we're going to have mesocyclones that will produce tornadoes. After that, go ahead.
Oh, no, go ahead.
Yeah, there are so many ingredients you can look at. We talked about, the cloud height, and, if you have tall cloud heights, storms could rotate all they want, but they'll never, the cone will never come to the ground. Those are typically your LP supercells that are prolific, large hailmakers. So, you need all these ingredients. So you could have CAPE, you need to talk about lifted index, you need to talk about, vorticity, you need to talk about energy helicity index, which is another really good poor man's version of combining instability with shear or spin in the atmosphere. I mean, think of all the different parameters you can look at. You can look at significant tornado parameter, the Craven's parameter. You can look at supercell composite parameter. You can look at all the different CAPEs. You can look at all these different things. I'll tell you the last thing I ever look at is forecast reflectivity. Last thing.
That's the last thing.
Jonathan, I know a lot of students too. I look a lot at photographs, and I think you can really kill a lot of birds here when you're forecasting on a sheer type of day. When you're not looking at just pure elevated convection, that it's going to be surface and elevated to the point where it's a tornado day. If you're that time of year, looking at your directional and your vertical shear that you were just talking about, you can combine both of those by just clicking on the photographs. And I think this one's from twisterdata.com. You can actually just hover over the map and click and get these. This was April 2010. I want to say Wichita sounding. And it shows what you were just talking about. The surface wind would be this very first point, and you really don't have any data to analyze unless you have more than one point. So it shows a south wind. This arrow, you can just draw arrows straight from these points in the direction of the next arrow, and that's how you know where the wind is blowing from. So you got strong south wind through the first column of air, and then it quickly turns over. So there's your directional shear. And in your speed shear, you're looking at the winds at the surface at about 10 to 15 knots, about 15 knots. But higher up in the atmosphere, you've got the winds at 50 knots. So speed and directional shear. And you're looking at this hook, and the space under the hook is essentially your total wind shear for the storm, your helicity. And if you can see this hook, then and it's got a lot of space underneath it, then you essentially have you essentially have enough wind shear and directional shear to produce a tornado. So this looks like it'd be a pretty bad day.
Actually, so if I pull up the storm reports from that day, we had a lot of wind and hail from that day.
But it didn't tornado.
It didn't tornado.
Oh, geez. Okay.
I like looking at photographs, but I find that photograph is based off a forecast sounding based on one target. So
Exactly.
The problem is, if you're forecasting just for Oklahoma City, then fine. But what happens if you have a large area that you're forecasting for? Then you have to cherry pick. You have to hunt and keep on clicking on the map and do all these photographs. Photographs, I think, are perfect for a fine-tuned forecast. But for the down and dirty, I will photograph, but it's the last thing I get to.
And probably, Brad, what happened, especially on that photograph that you're looking at, and then as we look at the storm reports, is that, again, it's all part of, you have to have all of those things come into play.
Exactly.
And so the photograph could have been perfect for a tornado outbreak, but maybe there's a cold front coming in. It's April, so you're probably going to have some type of front coming in that's going to produce that type of severe weather. Maybe the cold air undercut the storms, and that's why we didn't get the tornadoes that day. But that photograph, I mean, it was good. I mean, that's a sexy-looking photograph.
We have all those ingredients, and you use the word tornado. SPC issues at 10 or 15%, and then nothing happens, and it just boggles your mind. And even if it happened again the next day, you still have to forecast tornado, because it's always a good idea to over-forecast tornadoes than to under-forecast, because if people don't have their shelter cleaned out because you had a hunch that you didn't think it was going to happen, then that's when somebody gets killed.
There was a day last year, Brad, when it was before May 20th. It was in early April, and all the dynamics were coming together for this big severe weather outbreak. The wording from the Storm Prediction Center, they were saying long track, violent tornadoes possible. But what we were playing with here in Oklahoma City and across the state is that we had this cold front that was just stationary. And so the storms that popped and then went due north over the front became hailmakers because they went into the cold air. It was like 45 degrees. But the storms that tried to go turn more right, and stay in the warm air, those are the ones that we were concerned about becoming tornadic. And again, all the dynamics of the photographs looks good. I mean, the photograph, just like you put up, looked really good. But we didn't have any tornadoes that day because these storms just could not stay in that warm environment. It happens. It happens a lot. Forecasting tornadoes is not an easy thing.
I will say, the 500 millibar, my rule of thumb of 50 knots at 500 in May, that does not apply to June or July, because we just saw with those. I worked that night, the night of the Beaver tornadoes on the 22nd. I was working, and we had our storm chaser Buck King. He was on that storm, and it wasn't a classic setup. I mean, the storm was moving south-southwest, and the flow aloft was, at 500 millibars was 20 knots, but there was directional shear. And so the storm, which I honestly thought the storm would collapse, it just kept riding the cold pool south, and it constantly maintained inflow, and it wouldn't collapse on itself, so you didn't need the flow aloft, but you did have the directional shear, and that was the magic. And this time of year, again, I'm huge. It's all about outflow boundaries. Look at the Memorial Day Lacey Pig Farm tornado. I worked that. That was in 2007. We had tornadoes 3 days before. Finally, an MCS went through. It was a Saturday, and MCS was laid down an outflow boundary, and it was kind of under forecast. And boom, you had how many tornadoes that day from one supercell? Discrete tornadoes? I don't know, 10, 12, I don't know. Some of them were what biggest was an EF3, and kind of a sleeper day. Outflow boundary, storm formed south of the boundary. It hit the boundary, and that's where your low-level shear was just cranked. You had southeast winds at the surface, and that really got it going. I can name dozens of tornado days that it was all about the outflow boundary. And right now, we can have that. We can, no flow off, great instability, high instability, dew points in the 70s, highs in the 90s, no flow, and you get kind of air mass storms, and here comes the outflow boundary. Storms go over the boundary, boom, tornado. It's not a long track, long-lived violent tornado. It only needs to be on the ground for 5 minutes to impact somebody. So,
we had some incredible outflow boundaries yesterday afternoon in these storms that were down in southern Oklahoma. And actually, this is just a screen grab so people know what we talk about when we say outflow boundaries. I kind of have this saying. So imagine, if you will, that you have that you basically have a water balloon and you're holding it above the ground, and you drop the water balloon, it hits the ground, and then that water just spreads out. Well, a thunderstorm does the same thing sometimes, where the air just rushes out, it hits the ground, and it spreads out, kind of like when you drop that water balloon and the water breaks out. So you can have these boundaries that develop, and you can see them quite clearly on radar. It's just these little, almost like a little mini front, and it's just advancing across the screen. And when you have those in play, anything's possible. I mean, they usually say cut off low is a weatherman's woe, but man, you put in an outflow boundary in there, and that can, I don't know what we can rhyme. What kind of acronym? What can we say for an outflow boundary? They're tough. They are tough to forecast.
Pull that back up, Damon. That was really impressive. I don't know if I've ever seen one quite completely circular like that around the entire storm. That's quite bizarre. Where there's an outflow boundary going in every direction from a single thunderstorm. Quite unique. And what you're seeing there, I guess, too, is these get really impressive. And I would say in Nebraska that it's more vivid like that because of all the dust that's being kicked up.
Yeah.
And you've got a big wall of dust coming at you.
And these storms are probably like this one that's just south of the radar site. That's developing because of that outflow boundary, and then this one on the bottom right-hand portion of the screen here, that storm right there is developing off of that outflow boundary. So yeah, when these things are around, you can see them. We had some. And it's very common even here in Oklahoma to get them. So. They're tough to handle. One thing I did want to mention, actually, real quick, I wanted to show this because we talk a lot about Storm Prediction Center and slight, moderate, high risk. This was the risk for. Let me start the screen share right here. This was May 3rd, '99, and I thought this was probably one of the most unique risk maps because there's no moderate. They just went slight. High during the afternoon. And May 3rd actually started out as a slight day. There was supposed to be a cirrus deck of clouds that came in and was supposed to limit the thunderstorm potential for May 3rd, '99. That deck of clouds didn't ever really make it in, so we got a lot warmer. The instability cranked up, and by that afternoon, this was the risk for that afternoon. But I always look at this and think, wow, we just went from slight straight up to high. There was no moderate thrown in there whatsoever.
Well, hopefully no one was taking a nap on that day. I wasn't here in '99, but gosh, talk about a rude awakening for work. And then of course, what happened?
I've heard some stories. I definitely heard some stories about, just people that went in that day. We walked into work on May 20th having a pretty good idea that, this was probably going to be a
the
pretty
last
bad day.
couple days, yeah.
Yeah, May 19th was bad. Nothing had changed. And so, but you talk to some meteorologists in the plains from Wichita, Tulsa, OKC down the Lawton that day, and they'll tell you, like, they just kind of came in, weren't really thinking much of a big outbreak on May 3rd, and look what happened. So there's definitely.
And Damon, I think too. We're not constantly as meteorologists. While I'm at home, I'm not always looking at every model. I mean, we have lives to live as well. So we will double check what we're doing with the SPC, with what the local weather office is doing. I know for me, when I make my weather forecast, I don't look at any of the Weather Service data other than model output statistics and modeling numerical models. I will make my forecast, and then I will double check what I've done with the weather office by reading their forecast discussion, because we're capable of missing things. We're not going to claim that we have it all together, because there is so much to look at, and for TV broadcast people, we only have such a limited amount of time. We're taping podcast and weathercast and doing radio hits. There are several guys and gals constantly just forecasting. So we go back and we double check what we're doing. At least I do, and I think you guys probably do too.
Oh yeah. Well, you have to. You kind of have to see. Like I go in, make my forecast, and then the last thing I do is kind of look, say, oh, what's everyone else doing? But usually at that point, I'm so deep into the forecasting game that day that I'm not going to really tweak anything. Hey, it's almost 12:50. I'd love to keep this conversation going. I really would, but I gotta get ready for work. Anything else you guys want to add?
I understand. No, we gotta go, but I enjoyed it.
Yeah, I did too. Jonathan, anything you want to add?
No. What do you guys think is going to be the big hurricane this year?
Oh,
Nate,
man.
you have pick a name of all the hurricane names. 2014 hurricane names. I don't think anyone of us are going to be on the name list for. I think Danielle is in 2016.
I'll go
She's
with
not
the F-storm.
They
If you
never
had to pick one, pick a name. Here are all the names: Arthur, Bertha, was it Cristobal, Dolly, Edward, Faye, Gonzalo, Hannah, Isaiah, Josephine, Kyle, Laura, Marco, Nana, Omar, Paulette, Renee, Sally, Teddy, Vicky, Wilfred. Pick a name. Which just for fun. Which one do you think is the strongest?
We feel pretty confident that this year isn't going to be like that one year when we had to go into the Greek alphabet, huh?
Right. That's 2004, right?
Yeah. So, oh man, gosh.
I'd say, playing it safe, the first few down the list, our tropical waters only heat up, peak season is September. It's slow start now, so I couldn't see us being any farther along than E, F, or G, even in peak season.
I'm going to go with Hannah.
Hannah? Now, this is nothing scientific, okay? My money on the strongest, biggest, most impacting hurricane for the United States.
Man, you're throwing in a whole bunch of different...
Yeah, there's so many different categories. I'm Marco.
You're going Marco?
Marco.
Wow, you're going for a busy year then.
Now, I'm not going busy year, because I think most of them, well, I guess named storms, yeah. I'll go Marco. Marco's the biggest, strongest hurricane.
13. Okay.
Bertha sounds pretty, I don't know.
I already see the headline, right?
Yeah.
The first person
that one.
like that should be fired. Okay, so one other guess. It was July 9 last year. The first 100-degree day at Will Rogers in Oklahoma City. Will be?
This year?
Yeah.
Oh,
I know it's easy now that we're into July, but...
Soil moisture is pretty high.
David's going really into this. He's got soil moisture.
Soil moisture you can forecast really well just off of soil moisture alone.
It is July. It doesn't matter so much, right?
I'll go 15th.
Okay.
I forecasted 10 for the year. I'm going 10 100-degree days for the year.
What's average?
About 8 to 10.
All right.
I think.
So you're saying our first 100-degree day is the 15th of July?
Yeah.
Okay, Brad.
I'm gonna play the Price is Right deal.
Yeah.
And go the 14th.
And I'm gonna do the same thing. I'm gonna one up you.
Okay.
But the other way.
Oh.
I'll say after the 21st.
Wow. Hey, we'll remember this. We'll write this down. We'll tweet it out.
Get Danielle's. We'll text Danielle and see what hers is.
Okay.
All right. It was fun.
All right, guys. Have a good day. We'll talk.